Section 10.3, loan amortization. And this means the process and accounting of paying off a loan. Now, the overarching principle about paying off loans, that if you are clever with numbers and comfortable with them, the only thing you need to remember is that interest is paid first. This is the principle upon which everything flows for loan amortization. So if you are really good and clever, this is all you need to know. So let's do an example of an entire loan amortization schedule. We have a loan of $563 at 12% annual interest, compounded monthly. And we make equal payments of $116 at the end of each month. Okay? So, now there's no rule that you have to make equal payments, but that's usually how people like to pay back loans. They get paid monthly, and so they want to budget monthly, and they want to pay an equal amount each month. So here's how it works. I'm going to draw the table here that shows what's going on. I'm going to look at the end of month, and this is going to be a number, like 1, 2, etc. I'm going to look at the payment made, and this is going to be $116 for each month that we do this. I'm going to look at the interest due. I'm going to look at the amount applied to balance. And I'm going to look at the balance. So I'll give you a second to write all those columns, because that's going to take you guys a little bit. And now we're going to start filling in this table. So, you took out a loan at the beginning of one month, right? And at the end of the month, you're going to owe a payment. Now, the loan is at 12% annual interest compounded monthly, so that means each month the interest is 1%. So the interest due at the end of the first month is 1% of the balance. The interest due at the end of the first month is 1% of the balance. So the interest due is $5.63. Okay? So when you make that payment of $116, following the general principle of paying off a loan, the first $5.63 from that payment pay off the interest. The rest of that payment, the remaining $110.37, is applied to the balance. That means the balance next month is not $563, this shouldn't be $563. This should be what remains of the $563. It is $452.63. We take $563 and subtract $110 and change. Okay, so that's the end of the first month. Then we come to the end of the second month. We make our $116 payment, but the first thing that occurs is we must pay the interest. How much interest do we owe? We don't owe $5.63 anymore because we don't have a loan for $563 anymore. Now we have a loan for $452. So now our interest due is $4.53. We have a little less interest due because we have a little less outstanding on the loan. The rest of the payment, which is $111.47, gets applied to the balance. So I take the 452.63 and I subtract the 111.47 to get 341.16. Okay, now I'm going to pause. Please let me know if you're not seeing where I'm getting any of these numbers, because I'm not showing it in detail. I'm trying to make a clean table, but I can show in detail and then erase it if you're wondering where any of those numbers had come from. Is anyone wondering where any of these numbers are from? Speak now, or just commit yourself to being further confused. Emmett?
Only the 4.53.
Oh, okay, so where did that 4.53 come from? Well, when you paid your first payment, some went to interest, the rest went to the balance. You took out a loan for $563, you paid $116. Now $5 and change went to interest, but the rest went to the $563. This number is $563 minus $110.37. That's where we got that number. Now, the end of the next month comes, you owe interest not on the full $563, but only on the balance due. You only calculate the previous balance to look at the interest due. So 1% of 4.52.63 is 4.53. So that's where the 4.53 came. So Emmett, what number should go in for the next month there under interest due then? Instead of 4.53, it's going to be?
So we're calculating the most recent balance now?
Yeah, 1% of 341.16.
It's going to be 343.41.
Exactly. So that's where that number comes from. And of course, we make our $116 payment again. The amount applied to the balance now is a little bit more, $112.59, because we first take out the interest, and then we apply the rest to the balance. And now the new balance is $228.57. Another month passes, and now we pay our $116. The interest we owe is $229, because that's 10% of the balance over here. Now we get a little bit more going to the principal, $113.71. Now the new balance is $114.85. And then we make a final payment of $116. Our interest due is now $1.15. The amount applied to the balance is the remainder, which is $114.85, and that exactly cancels out the balance. Okay. So why did this come out exact? Because this question was done ahead of time to calculate exactly what monthly payment would make the loan be paid off in exactly that manner. Okay. Any questions about this? Okay. So, all loans work in this manner, basically. Obviously, that you might have interest due versus, there's some complicated things that might, but basically this is the principle that applies to all loans, is you pay the interest first. Okay, so there's a formula to calculate the rent, or what we usually would say is the monthly payment. And if you want to find the rent, you take the interest rate per period, and you take the number of payments, and P, you have the principal of the loan, and the formula is the monthly payment or rent, or what the periodic payment. We don't know if it's monthly or yearly or whatever, but the rent is going to be I divided by 1 minus 1 plus I to the negative n power times P. That's the formula that you want to memorize or write down on the sheet of paper for the exam. And if we apply this with this problem here, let's show how this works for the problem we just did. The interest rate is 1%, so it's 0.01. 1 minus 1.01 to the 5th power, because there's 5 periods, and the principal is 563. And if we compute that, we will get 116, which you can check if you have your calculator open and care to be curious about that. But that's how we would have done that for the previous problem, to find out the monthly payment. Okay, the most common way that people engage with loans is paying, of course, for a house or an automobile, right, with equal monthly payments. So let's do a home mortgage example. A home is purchased for $200,000 with a loan of $160,000 and a down payment of $40,000. So a traditional 20% down payment, the way most home loans work. The loan has a 3% annual rate with payments, or with the interest compounded monthly. This is usually how this works. And the loan is for 30 years. What are the monthly payments? Now, if you're a regular human being, you will Google mortgage calculator and you'll just pop these numbers into the little doohickey that some weirdo put on a web page that serves a bunch of ads, and then you'll have your number, right? But there's a math formula that they use, and it's not too difficult. In fact, we just saw it. It's this formula right here. So I just need to figure out what my various numbers are. The interest rate is going to be 0.03 divided by 12, because it's a 3% annual rate and everything is computed monthly. So this is going to be 0.0025. Okay, N, the number of periods, well, it's 30 years and there's 12 months in a year, so that's 360 months. 360 payments to pay off the mortgage. And the principal of the mortgage is $160,000. So those are all the numbers we need. And I'll use this formula here. R is equal to 0.0025 divided by 1 plus 1.0025 raised to the negative 360th power times 160,000. And when you calculate that, you'll get $674.56. And in a moment, I'll show you how to do this on one of those time value money calculators. Okay. And if you are a business student, you should probably just buy one of those now and learn how to use it, because you'll eventually need something like that for an exam anyway. They're like 30 or 40 bucks. Obviously overpriced, but oh well. Okay, so let's get our calculator here. There's the things we need. Okay, so N is 360. So I'm going to hit 360 and then store that in N. The interest per period is 0.25. Remember, we don't put this in decimals, we just put it in there. The present value is $160,000. That's how much we're taking out. The future value, well, we want to pay off the loan completely, so we store 0 in the future value. Then we hit compute, and I'm going to hit the payment button, and it's going to pop out that same $674.56 that we computed with the formula. Okay. So that is how you calculate a payment for a loan. Let me see how much. Okay, yes, I've got enough time to talk about the two things I want to talk about. So one question here's a question to ask. What is the interest paid on the first payment? We pay $674, and how much of that goes to interest? Well, let's look at this, right? Our loan is $160,000, and we have 1 month of interest. So at the first day of the month when we got the loan, we owed the bank $160,000. But at the end of the month, or the first day of the next month, we owe the bank a little bit more because we've been borrowing the bank's money. We now owe the bank the product of $160,000 and 1.0025, which is $160,400. So actually, the interest that was added is $400. So of that $675.56, most of it, almost 2/3 of it, goes to pay the interest. And then we have $274.56 going towards principal. And all loans work like this. At the beginning, much more of your money goes to pay interest than for principal. For a long-term loan. Right? For a long-term loan, that you'll be surprised when you buy a home someday, and God willing, if you buy a home someday and you get that first bill and you're like, wait, nothing is going to the principal, basically. That's just the way of the world, because you have to pay the interest first. The interest is always paid first. Okay, so that's how you calculate that. Another thing you might want to know is a formula for the unpaid balance. Of a loan. And this is the same values from before. So the unpaid balance is 1 minus 1 plus I to the negative n divided by I times the payments, where the only thing that's a little bit weird about this formula, this n, is the number of payments remaining. Not the number of payments you've paid, it's the number of payments remaining. That's what that n is. So you could say, how much do you owe on the house after 10 years of mortgage payments? Say at the end of 10 years, you're like, I'm sick of this. I got a big bunch of money that I inherited. Can I just pay off the house? You might ask. So to figure that out, we take 1 minus 1.0025 raised to the negative 240 power divided by 0.0025. 240 because there's 240 payments remaining after 10 years. And then we multiply that by the monthly payment, $674.56, and we get $121,630.53. That's how much we would owe after 10 years of making payments on the $160,000 initial loan. That's more than 1/3, or that's more than 2/3 of the remaining balance, because you always pay the interest first. Okay, let me get you the homework assignment and let you get out of here because we're almost out of time. This is section 10.3, numbers 2, 4, 6, 8, 12, 16, and 22. Okay. All right, folks, have a good weekend.